Let me ask you something. When you picture the deep ocean floor, what do you actually see? Most people picture darkness, flat darkness, maybe a few strange fish, mud stretching out in every direction. That is a reasonable thing to picture. For most of the ocean floor, it is even accurate. But there is a version of the deep ocean that looks nothing like that. A version with white towers taller than a 15-story building, standing in a total darkness, built by nothing and no one, still standing there right now while you watch this. I did not know this existed until I started reading the actual expedition reports. Not the summaries, the reports. And what I found in them changed how I think about what counts as alive. So that is what this documentary is about. Not the ocean floor you are picturing right now, the one underneath it, the real one. Stay with me, because this gets stranger the further in we go. Let us start with where this is, because the location matters more than you would think. Running down the middle of the Atlantic Ocean, roughly equidistant from the Americas on one side and Europe and Africa on the other, there is a mountain range. Not a small one. It is the longest continuous mountain range on the entire planet, stretching for approximately 65,000 kilometers if you follow the full global system it belongs to. For comparison, the circumference of the Earth at the equator is about 40,000 kilometers. This mountain range, if you could somehow unspool it and lay it flat, would wrap around the entire planet 1.5 times over. And you have almost certainly never seen it, because roughly 90% of it sits entirely underwater. This is the Mid-Atlantic Ridge. It rises about 3 kilometers above the surrounding seafloor, which puts individual peaks within it in the same general height range as some of the taller mountains in the Alps. An entire alpine mountain range hidden under the Atlantic that most people alive today have never heard mentioned once. Here is what I want you to understand about this place before we go any further. It is not a static feature, like a mountain range on land that mostly just sits there, weathering slowly over millions of years. The Mid-Atlantic Ridge is where the seafloor is being manufactured. 2 tectonic plates are pulling apart from each other here, right now. And as they separate, hot rock rises from deep in the mantle, melts under the drop in pressure, and cools into brand new ocean crust. The Atlantic Ocean is, quite literally, getting wider because of what is happening along this ridge, roughly 2.5 centimeters a year. That sounds trivial. It has been happening long enough to open an entire ocean basin. By the year 2000, scientists thought they understood what you would find if you went looking along this ridge. Hydrothermal vents, the famous black smokers, chimneys of dark mineral-rich fluid billowing out at temperatures between 200 and 400 degrees Celsius. Hot enough to warp the shape of what most people imagine when they think of the deep sea floor. Life clustered around those vents, powered by chemical energy instead of sunlight. This was already known. This was already, by the standards of ocean science, an established picture. And then, on a research dive that was not even looking for any of this, that picture broke. On the 4th of December, 2000, an expedition funded by the U.S. National Science Foundation set out to study the structural geology of the Mid-Atlantic Ridge, led by researchers from the Scripps Institution of Oceanography, the University of Washington, and Duke University. Their goal had nothing to do with hunting for new ecosystems. They wanted images of the steep cliff faces, data on the faults, an understanding of how this particular stretch of oceanic mountain had formed. A flicker on a camera feed at 700 meters down changed the plan entirely. Ghostly pale shapes were rising out of the darkness in a location where the team was expecting to see nothing but ordinary sea floor. Whatever this was, it was not black. It was not what a hydrothermal vent was supposed to look like, and it was not where a hydrothermal vent was supposed to be. This location was 15 kilometers away from the ridge axis, sitting on crust that was already over 1,000,000 years old. Vents form near the axis, where the crust is young and the heat is fresh. Nothing should have been actively venting this far from that source. With weather closing in and time running out, the team used their one remaining dive of the expedition aboard the submersible Alvin to go down and look directly. What they found when they reached it was a landscape of towers, some rising 60 meters from the seafloor. For a sense of scale, that is roughly the height of a 15-story building standing in complete darkness, 700 meters below the surface of the Atlantic Ocean. At the time, it was the tallest hydrothermal structure ever recorded, and the surfaces of these towers were pale, almost luminous, like limestone ruins in a place limestone ruins have no business being. They named it, on the spot, the Lost City. Here is what I want you to sit with for a second. This was not a myth. This was not a legend embellished over centuries of sailors' stories. This was a research team in the year 2000 looking at real-time camera footage of a structure that, by every rule they understood about how hydrothermal systems work, should not have existed in that location, at that scale, made of that material. Because when they finally got close enough to sample it, the chemistry made even less sense than the geography. Ordinary black smoker vents are made largely of metal sulfide minerals, driven by magma sitting close beneath the seafloor, heating seawater to temperatures that can exceed 350 degrees Celsius before it blasts back out. Dark and mineral-laden. The Lost City's towers were made of carbonate minerals and something called brucite, a soft, pearly white to pale green mineral form of magnesium hydroxide. Some vents here discharged fluid around 75 degrees Celsius. Some flanges held shimmering pools closer to 50 or 55 degrees. Warm, in other words. Not the furnace heat of a typical vent field. A hot bath, sitting quietly in the freezing dark, 3/4 of a kilometer down. And there was no magma chamber underneath any of it. Let that sit for a moment, because this is the part that took geologists years to fully process. Every hydrothermal vent field known up to that point was, at its core, a heat engine driven by molten rock close to the surface. The Lost City had no such engine, and yet it was standing there, 60 meters tall, warm, and alive. So, if it is not magma, what is actually powering this place? The answer sits in the rock itself, not beneath it. Along slow-spreading ridges like this section of the mid-Atlantic, the seafloor can tear open along long-lived faults, exposing rock that normally sits deep within the oceanic mantle. When seawater works its way down into those fractured mantle rocks, it comes into contact with a mineral called olivine and reacts with it in a process geologists call serpentinization. This reaction does something remarkable. It generates heat on its own, simply from the chemical transformation of the rock. It also produces hydrogen, methane, and highly alkaline fluid. When that fluid rises and mixes with the cold seawater above it, it precipitates carbonate and brucite, the exact pale minerals that built every tower in the Lost City. In other words, nobody is burning anything down there. There is no furnace. Seawater is sinking into cracked mantle rock, being chemically transformed by contact with the rock itself, and returning to the ocean carrying energy that life, it turns out, can use directly. Here is why that single fact matters more than almost anything else in this story. For decades, the discovery of hydrothermal vents in general had already overturned one of biology's oldest assumptions, that all life on Earth ultimately depends on sunlight. Vent ecosystems prove that life could run on chemical energy instead, in complete darkness at the bottom of the ocean. The Lost City went a full step further than that. It showed that life does not even need volcanic heat to do this. It can run on nothing but the slow chemical reaction between seawater and rock. No sunlight, no magma, just rock, water, and time. And it is not merely surviving down there, it is thriving. The towers are coated in thick microbial mats, dominated by a group of organisms called archaea, ancient single-celled life forms that do not breathe oxygen and do not depend on anything resembling a plant. They consume the hydrogen and methane produced directly by the reacting rock. That is their entire food source. Swarms of translucent shrimp, snails, and small arthropods live across the surfaces of these structures as well, sustained by an ecosystem built from chemistry that has almost nothing in common with the world on land, or even with an ordinary black smoker vent. Are you still with me? Because I know this is the point in a video where a lot of people start drifting. The visuals are strange, but there is no immediate danger here, no ticking clock, nothing that grabs the lizard part of your brain the way a shark or a storm does. I get that. But stay with me for what comes next, because this is where the story stops being about one lucky discovery and starts being about just how much we still do not understand about our own planet. When that 2000 expedition ran out of time, they left with more questions than answers. They did not know how old the Lost City actually was. They did not know whether the towers were fixed permanently in place or slowly shifting. They did not know how far this kind of venting extended along the ridge, and critically, they did not know if the Lost City was a complete one-off, a freak accident of geology that would never be found anywhere else on Earth. It took years of return expeditions to even begin answering those questions. In 2003, largely the same research team returned aboard the research vessel Atlantis, this time bringing an autonomous underwater vehicle nicknamed Abe to produce detailed sonar maps of the site. Over the course of that expedition, they collected over 100 rock samples, close to 200 vent fluid samples, and more than 150 microbiological samples. They made 19 separate dives to the site using the submersible Alvin. In total, they mapped a dozen distinct vent structures spread across an area of roughly 1 square kilometer, including one they nicknamed Poseidon, standing nearly 61 meters tall on its own. And then came the question that, to me, is the most staggering part of this entire story. How long had this been here? Isotope and radiocarbon analysis gave an initial estimate. At least 30,000 years. Already an almost unimaginable span of time for a hydrothermal structure to sit quietly on the seafloor, entirely unknown to anyone. But as more detailed mapping, imaging, and direct observation accumulated in the years that followed, that estimate did not just increase, it roughly quadrupled. Current estimates place the Lost City's minimum age at around 120,000 years. 120,000 years. Modern Homo sapiens had barely begun spreading out of Africa when this system was already active. Every civilization that has ever existed, every war, every book, every language ever spoken, happened entirely within the lifespan of this single quiet chemical reaction, sitting in darkness 700 meters down, in the middle of the Atlantic. And for all but the last 25 years of that 120,000-year span, not one single human being knew it was there. The obvious next question scientists needed to answer was whether the lost city was truly unique, or whether there were others like it waiting to be found. This turned into one of the more grueling, multi-decade searches in modern ocean science. The National Oceanic and Atmospheric Administration and the Schmidt Ocean Institute combined efforts and launched a targeted expedition, appropriately named In Search of Hydrothermal Lost Cities, focused on a 700-kilometer stretch of the Mid-Atlantic Ridge. They used shipboard multi-beam mapping, instrument packages measuring conductivity, temperature, and depth, chemical plume sensing, and a remotely operated vehicle equipped with real-time methane sensors, essentially every detection tool available at the time. What they found was genuinely valuable and also a little humbling. 3 new hydrothermal vent fields, all conventional black smoker-style systems, driven by magma in the usual way. Interesting discoveries in their own right, but not a second lost city. The search continued for years after that. In 2017, at a depth of roughly 3,100 meters on the southwest Indian Ridge, researchers found a field driven by the same serpentinization chemistry and named it, with what I can only assume was a slightly exhausted sense of humor, the Old City. The underlying chemistry matched, but at that depth, under that much greater pressure, the physical conditions did not favor the growth of 60-meter carbonate cathedrals. What formed there was smaller, more modest, a chemical cousin rather than a physical twin. Then, on a separate expedition using the Schmidt Ocean Institute's research vessel, Fall Core, equipped with some of the most sensitive methane detection equipment ever deployed at sea, sensors suddenly lit up near a feature called the Von Dam site, close to a massive underwater structure called the Pico Vent Field. For a moment, the excitement on board was, by every account from the scientists involved, electric. Had they finally found it? A second white metropolis? What they found instead was a black smoker field running at roughly 340 degrees Celsius, hot enough to melt lead. A spectacular discovery in its own right, the first vent field found in that particular 640-kilometer stretch of ridge in over 40 years. But it was not the lost city's twin either. Here is what all of that searching actually tells us, and I think it is worth pausing on this rather than rushing past it. To build something like the lost city, you need an extremely specific, almost accidental combination of conditions. The right kind of mantle rock exposed at exactly the right depth, low enough heat that magma never takes over the process, and an enormous undisturbed span of time for those towers to grow, uninterrupted, layer by layer. That combination, it turns out, is not just rare. As far as we currently know, it may be closer to unique. Decades of searching across multiple oceans have found chemical relatives. Nobody has yet found a true twin. This is why NASA, alongside the oceanographers, keeps a close eye on what happens at the lost city. Because if life here does not need sunlight, and does not need volcanic heat, and can run entirely on the chemical reaction between water and rock, then that same basic process could theoretically be happening right now, in places we cannot directly observe at all. Consider Europa, one of Jupiter's moons, and Enceladus, one of Saturn's. Both are believed to hold liquid oceans, sealed beneath thick shells of ice, in contact with rocky cores below. Nobody has ever seen inside either of those oceans directly. But if the lost city's chemistry can sustain a thriving ecosystem in the crushing dark of the Atlantic, then the basic ingredients for the same kind of life, sunless, heatless, powered by nothing but rock and water in slow chemical conversation, may already exist on worlds tens of millions of kilometers from here. The lost city is not just a strange corner of our own ocean floor. It may be the closest working model we have for how life could exist on a moon we have never set foot on. And here is the part of this story that I find hardest to simply sit with. We are, right now, in the process of potentially destroying the very thing that gave us this insight before we have finished learning from it. The mid-Atlantic ridge and the mineral-rich crust surrounding vent fields like this one has become a target for deep-sea mining. Companies and governments are increasingly interested in the rare metals concentrated in these formations, driven by demand for the materials used in modern electronics and renewable energy infrastructure. The same remoteness and inaccessibility that kept the lost city hidden from human eyes for 120,000 years is now, ironically, part of what makes it a target. Few witnesses, little oversight, enormous economic incentive. Scientists studying these systems have been direct about the risk. Destroying a site like this does not just damage a beautiful geological curiosity, it risks permanently erasing one of the only physical windows we have into questions about how life itself might begin. Questions we have not even finished asking yet, let alone answering. I think about the shape of this story a lot, and what strikes me most is not really the height of the towers or the strangeness of the chemistry, remarkable as both of those things are. It is the fact that this discovery on its own did not close a mystery. It opened one. Every major return expedition since that first accidental dive in 2000 has made the lost city more complicated, not less. Older than first estimated by a factor of 4. Chemically distinct from anything scientists had previously mapped. Still, after multiple international search efforts spanning decades, essentially without a confirmed twin anywhere else on the planet, for 120,000 years, something has been quietly building cathedral-sized structures out of nothing more than seawater and mantle rock, in a place with no sunlight, no volcanic fire, and no reason, by the standards we once used to define what a living planet requires, to be doing any of this at all. It was not a violent event, not an eruption, not a catastrophe, nothing that would leave an obvious mark in the geological record for anyone to stumble across easily. Just a slow, patient chemical engine running continuously, hidden under 700 meters of the Atlantic for a span of time longer than the entire history of our species walking upright. We found it entirely by accident, with one dive, on an expedition that was not even looking for it, running out of daylight before a storm. I keep coming back to that detail specifically. How much of what we think we know about this planet is built on the assumption that we have already looked closely enough? The ocean floor felt understood in the year 2000, right up until the moment a camera feed showed something pale rising out of the dark where nothing pale was supposed to be. The surface is not the whole story. It never was. If this documentary gave you something you did not have before you pressed play, if the ocean floor feels even slightly different to you now than it did 20 minutes ago, then subscribe to Abyss Files. Every week we go somewhere the surface does not show you. Every week there is something the ocean is still hiding, and I promise you, it only gets stranger from here.